Hi everyone and welcome to this channel. Today I'm gonna go through rational indices and roots. First I'm gonna start with some basics rational indices. So here basic rational indices and rules. The first one we have is a to the power of n, a to the power of 1 over n. 1 over n is equal to nth square root of a. So you can see that number 1, this one here, so it goes here to the power of a, and n is the n and root. So simplified version, usually if we have a to the power of 1 like we have here, we don't write number 1, we just leave it as a. Here's an example. Example 4 to the power of half is equal to, so it's same as what? Square root of, now number 2, this one here, so it was n here, it goes there, and 4, number 1 here. So 2, square root of 4 without 1, and then equal to. Now we do know that if we have number 2 here, we don't know yet, but I'll show you in the next line. So we don't write it, so it's just like square root of 4 and then is equal to 2. Or we could have is equal to, we still have that, and or second root, and number 4 is the same as 2 to the power of 2. Now what we can do is cancel out 2 and this 2, and the answer is going to be equal to 2. So the next line here, this one here, so we have a to the power of half is equal to, similar as in the line above, so square root of a, number 1, it's here, but because it's 1, just 1a, we don't write it. Number 2 here is second root, and when we have second root, so we don't write that number 2. So this 2 here, so if there is no number, then we know it's second root. So the next one is complex rational numbers, complex rational indices actually. So the first one, an example rule, we have a to the power of m over n equal to, now we're going to square root, going to copy a, and then if you remember from before, m goes, I'm just going to go with like this, yeah, m goes here and n goes there, okay, so it's going to be nth root, and this is the power of a. And this is equal to, you know, like same as I had before, but I just had that line, so without lines. For example, if we have a to the power of 1/3 equal to, we're gonna have root, the third root, and then a, the third square, the third root. The third root of a. So again, I'm gonna have this line here, so this number 1 goes here, but we don't write it because it's 1. And then we have example here, a to the power of 1/3, so we're gonna write, okay, third root and then 8. And if we want to simplify this, I'm just gonna copy this, and usually then we're looking if we can find you know, if we can write 8 as a number to the power of 3. So in this case that's going to be 2 to the power of 3, because 2 times 2 times 2 is 8, and then we're going to cancel out those, and the answer is going to be equal to 2. So please note, I have something up here. So Okay, I'm just gonna go like this. Okay, so a to the power of half is equal square root of a. A to the power of 3 over 2 is equal to square root of a to the power of 3 is equal to square root of a to the power of a to the power of 2 is equal to square root of a times square root of a to the power of 2, and then this is same as, okay, I can cancel out this and this, and we are left with a times square root of 2. Similarly, we can write a to the power of 5 over 2 equal to a to the power of 2 square root of 2. So usually they are used in year 12s a lot when you want to apply operations of differentiation. So, but I just thought I'll just put it out there, so if you would like to have a look at that. So let's have a look at some examples that we have here. So we have 36 to the power of half. So now we already know 2 is here. Okay, so I thought maybe not to write it, but 2 is there. So 36, and that is equal to 6, which is square root of 36 is 6. So this is the same as here, 9. Square root of 9 is 3. And then equal to this one, we have 9 to the power of negative half. We know when we have negative indices, if we want positive, we're gonna move, if it's in numerator to denominator, if it's in denominator to numerator. So this one is numerator, so you're going to move it to a denominator, it becomes positive, so which means you're going to have 1 over square root of 9 and is equal to 1/3. Okay, the next one, square root of 3, okay, to write in index form, so the same as 3 to the power of half. The next one, 4, is the same as to the power of 1/3. So this one, okay, I'm gonna go like this first. So it's gonna be 4 to the power of 1/3, but I'm gonna move it to numerator, and then the index is gonna become negative. Now this one here is the one, if you remember, from complex rational indices, 3, 27. So we're looking 27, what could be the base? So 2, it's not really good. What about 3? 3 times 3 is 9, times 3 is 27. That's beautiful. So you can have 3 to the power of 3. Cancel out those 3's, and we're going to be left with 3. So 4 here, 16. Now, you know the base, we're looking at 2. So you can always check that one, and is equal to 2, because we can cancel those. Let's have a look what we have on the page. So this one is short one, square root. So the square root of a number, so square root of a number a is the positive number, which when squared gives a. So the square root, oopsies, so I deleted that. Okay, what I need, this one here, the square root of a is written like this, square root of a, like this. Okay, square root of a, it's written like that. Example, square root of 16 is equal to 4, since 4 to the power of 2 is equal to 16. Square root of 49 is equal to 7, since 7 to the power of 2 is equal to 49. And now we have here other roots, which you have already seen. So pretty much this one is telling you here, if we have n here and n here, if they're the same, so they cancel each other, and you're just going to be left with a. Example, you have seen this one before. So with 27, and then this is going to cancel out, it's going to give you 3. We already had this one before as well, but that's fine. Cancel out is equal to 2. We didn't have this one. maybe we did. So 8 is written is the same as 2 to the power of 3. We can cancel those and is equal to 2. And I think that would be all for this lesson. Thank you, and I see you next time. Bye.